Hello, everyone. My name is Luke Gigiano, a lead SOC analyst here at ECS Tech.
Thanks, Luke. And I'm Dave Howard. I'm the director of the Cyber Threat Analysis Center. We call it the CTAC at ECS. So within CTAC, we have the SOC 24 by 7 by 365 operations. We've got the threat intel team, vuln management, and our red team. Collectively, those teams provide defensive and offensive security services to federal and commercial customers on behalf of ECS. So we're going to talk about a few things today. First, I'm going to walk through our Elastic journey, highlighting a few initiatives that provided very positive outcomes for a large federal customer. Next, Luke will talk about a deep dive focused project that the SOC underwent that really changed how we do business when it comes to analytic management with the SIEM. Finally, we'll collectively talk about some successes that we've had implementing threat hunting and machine learning in the SIEM. So a little bit about ECS. We are headquartered in Fairfax, Virginia, with over 3,700 employees across the globe. We are a leading provider of solutions in science, engineering, and advanced technologies. Those include things like cybersecurity, cloud, and big data, to name a few. We provide solutions for customers across all verticals, whether it's commercial or state, local, or federal governments. And then finally on the slide, we hold strong partnerships with leading technology companies, the strongest of which arguably is Elastic, which brought us here today. Luke? So thinking about our journey with Elastic, it really began back in 2018 when we partnered to provide the Cybersecurity and Infrastructure Security Agency, or CISA, a new dashboard for continuous monitoring and mitigation of threats and vulnerabilities across their ecosystem. This ended up being a game-changing upgrade to a legacy solution as part of the CDM dashboard, which you all know provides cyber awareness data to federal agencies and summarizes risk across the federal government or the Department of Homeland Security. Skipping ahead, in 2020, we expanded to the federal and intel community spaces, and then in 2021, we brought back that deep expertise that we gained serving those large federal customers to the commercial space, which is where Luke and I work today. So thinking about our global Elastic operations, we're a leading Elastic partner with proven results delivering capabilities across many deployment types. You see on the slide from endpoint security to dashboarding to observability, and of course the SIEM, which is what we're going to talk about today. We've done it time and time again. It's repeatable for us, and we're very good at it. Looking at quick facts on the right, we hold over 100 Elastic certifications. I'm told the largest of any company in the world. We continually collaborate with Elastic to develop new product capabilities that we bring to market, again, for both commercial and federal customers. And then finally, we've really become a leader and powerhouse in migrating customers from old security stacks to Elastic, and that's served us well as well. So last slide for me before I kick it off to Luke is our strategic partnership. We manage one of the largest deployments in the world. I mentioned CDM, I'm talking about that. We maintain strong executive level relationships and hold a seat on the partner council board. And then finally, we really are full steam ahead with providing end-to-end services for customers. So from here, I'm going to pass it off to Luke to talk about a focused project that we underwent late last year to optimize security ops using Elastic. Luke?
Thanks, Dave. I was the project technical lead on a project I will be talking about today and sharing with you about how our team performed advanced Elastic tuning to dramatically optimize our security operations. Starting with our mission, I think a place to start here is to tell you about the problem that we faced that prompted this mission in the first place. And that being an unmanageable number of alerts, approximately 287,000 in a given month across a sample of our Elastic clients. This being a daunting number of alerts leading to alert fatigue, since they were largely consisting of duplicate alerts or noise, which made it hard to identify and investigate the alerts that represent real active threat events. Additionally, our team wanted to start ingesting alerts into our SOAR solution. Our SOAR engineers came back after looking at the data we wanted to be ingested and said there were too many alerts. Simple as that, to ingest properly without degrading the system performance. So our mission seemed pretty clear at that point. Assemble a small tiger team of analysts with expertise in using Elastic SIEM with the sole focus of optimizing our Elastic detection rules to reduce the alert volume so that we could begin ingesting Elastic alerts into our SOAR. We began identifying the top 10 noisiest rules for each Elastic client. And over the course of a 3-week Tiger Team sprint, we optimized those detection rules by reviewing, tuning, or otherwise modifying them to generate fewer alerts while maintaining, or in most cases, improving the rule's integrity and effectiveness. So what does that tuning process actually look like in production? This is the high-level 3-step tuning process we're able to repeatedly implement to optimize our Elastic detections. Step 1 being develop a deep understanding of the detection rule itself. So identify the purpose of the rule, review the things like the description, investigation guides, associated references, and then identify how it works by reviewing the logic of rule runtime, which indexes it's querying. Step 2 being review the alerts. Validate the events that we are seeing as alert logs should actually be detected on. And if they're not, that's an issue, obviously. And then outside of that, review the alert event spikes or trends and attempt to correlate them. This is often a good place to start focusing tuning efforts later on. And then step 3, based on the findings from step 1 and 2, tune the rule in one or more of the following ways. The first way is by adding a rule exception. This is an exception value that has been correlated to alert trend or spike and would have a high impact on the overall alert numbers. The second way is by adjusting the rule query logic or query filters to increase the rule's effectiveness or precision. For example, perhaps for a given detection rule, you are not interested in events that came across from a particular data source or part of a network. You can just simply adjust the query logic to filter out those events from ever even being seen by the detection rule in the first place. And then the third way is by changing the rule logic type, i.e. custom query versus threshold versus EQL rules. Those are kind of like the big three. There's a couple others, but focusing on those. So you can change the rule type to a type that would improve how the rule works or how the alerts will be presented and or correlated. So those are kind of like the high level process of what we've done so far and have developed as our tuning process. Moving forward, our results. So after the 3 weeks of our Tiger team implementing our tuning process to optimize the top triggering alerts across all of our clients, we had dramatically reduced the alerts triggered in Elastic. So the same sample of Elastic clients that had approximately 287,000 alerts triggered in a given month for them now have approximately 21,000 in that same amount of time, which is a huge win. That's approximately 94% alert reduction over a month period, which is incredible. So we gave that information to our SOAR engineering team. They reviewed the post-tuning alerts per month numbers, and we're no longer concerned with the ingestion rate into our SOAR solution. At this point, we're happy to declare that the mission was definitely accomplished. So looking ahead and a new way to do business. So to start, we began frequently auditing alert metrics and trends. We now conduct weekly meetings with a rotating group of analysts to review alert trends across all of our clients and work together to optimize our detection rules. Continuously tune rules as the need arises. In addition to alert trend review, we have a Teams channel dedicated to Q&As about our detection rules and fixing any issues with them that may arise. Develop documentation and processes. The 3-step tuning process I shared earlier is just one example of the new documentation and processes that were created as a result of our mission. Another example is how we have begun conducting rule exception audits. And that kind of leads me to my next point, which is adopting new standards and best practices. So again, one of the things we have started doing is once a month, we will pick a client to review all the detection rule exceptions that have been made since the last audit. and review each exception individually to see if they are still valid and if they have a good exception comment attached to them. And then lastly, devote efforts to knowledge sharing and problem solving. So we've made a point to actively work with newer analysts or analysts that may not be as familiar with Elastic to learn about detection rules and how to build and investigate them. So value for our SOC that was gained by accomplishing our Tiger Team mission. To start, significant Elastic knowledge gain across all Tiger Team members. Again, alert tuning methodology developed, rule exceptions, best practices are now kind of known and established. Rule logic has been made more efficient and precise. Next, Elastic capability discoveries. Threshold rules have began being used to reduce the overall alert numbers by kind of correlating a bunch of related events together based on a couple of key values. Save searches have been created to make searching for data that is repeatedly looked for easier by simply loading the save search object. And then investigation timeline templates. So these have been developed to help newer analysts or just any analyst review alerts and show the logs in a templated sort of output that makes it easier to investigate. And then reduction in Elastic alert fatigue. So 94% reduction in Elastic alert count. That feeling of being overwhelmed from high alert counts hopefully is receding in our analysts. They're now less busy reviewing and closing alerts that should have been tuned or deleted and now have more time to innovate. And then lastly, Elastic rule housekeeping. So bad rules have been removed or revamped, rules with duplicated logic identified and removed, rules and error states identified and fixed, wildcard utilization within the rule logics has been reduced or to enhance system performance, that is. And then next. So what's most important to us is the value that this project has brought to our clients. So reduce costs to the customer because of our efforts to optimize our detection rules. Next, reduction in alert fatigue. Our analysts can now sharpen their focus and spend more time on the alerts that matter most, that actually represent active threats. So next is rule improvements made. So countless examples of rules have been improved. I think approximately over 100 rules were tuned throughout the course of this, just our mission alone, and they continue to be adding to that number week by week. And then next is logic that has become more efficient and effective at detecting only what was intended by that detection rule. Tuning performed with a priority to never compromise its ability to detect security events. And then lastly, we gained the potential to ingest that Elastic alert data into our SOAR and get SOAR metrics from that. So the original driver for the mission was to reduce the alert numbers to gain the possibility for ingestion, which would enable our clients to have better visibility into the efforts we put into triaging alerts in Elastic because they're seen in SOAR and then potentially our ticketing system. So one more point actually is investigation guidance and process improvements. So our team has discovered new ways to enrich and streamline our Elastic and alert investigations, which leads to lower times to remediation or escalations to our clients with more accurate determinations and recommendations at the end of them. So now passing it back to you, Dave.
Thanks, Luke. So the efficiencies we gained from that project have enabled us to shift our focus to some of the more advanced or sexy work in security operations. We're going to talk about threat hunting and machine learning to close this presentation out. So security operations is all about defending, and defending is hard. It's inherently reactive, where we put analytics in place to alert on potential malicious activity. The problem with this, as we know, is we often don't learn about intrusions until it's too late. And then we have to pivot directly into crisis management by way of incident response. So enter threat hunting. Threat hunting enables security teams to identify, contain, and then remove threats proactively with a presumed compromise mentality. And what I mean by this is threat hunters will structure a hunt or plan the hunt with the assumption that a known bad actor is already in their environment, often the case. The primary goal of threat hunting is reducing the dwell time of adversaries, right? And I think there's a misconception in the community that threat hunting is banging IOCs against the SIEM and searching for atomic IOCs. We know Bianco's pyramid of pain. We should be targeting those techniques, those TTPs that are very challenging and very costly for bad actors, APTs, and all the way down to cyber criminals to replicate or to change up on the fly. So speaking of TTPs, we're big fans of MITRE ATT&CK at ECS, and we use the framework to inform our intelligence-driven security operations or intelligence-driven hunting. Our hunt team, in coordination with our CTI team, threat models likely scenarios where APTs could potentially target either ourselves or our customers. Identifying threat actor TTPs and then overlaying that with current SIEM analytics or detections provides insight into potential security gaps in an environment, gaps that could be exploited by adversaries, and also gaps that are a good starting point for our hunt team. From there, our hunters formulate a hypothesis against which they will perform their hunt. Elastic for us is a force multiplier for our team's threat hunting operations, as it covers the attack framework with prevention, detection, and response. This enables our team to perform hunts against challenging scenarios. I have a few up here, like living off the land techniques, fileless attacks, lateral movement, and persistence. Again, this is to move us from reactive to proactive, the proverbial left of boom. Finally, we integrate our threat intel platform with our Elasticsearch to enrich logs to correlate known bad IOCs and TTPs, et cetera. This is part of the holistic XDR service we provide our customers. At a high level, that's some benefit we've found, from threat hunting, from tuning Elastic, freeing up time to do more of this advanced work, like I mentioned. Over to you, Luke.
So some more cool stuff that we're now able to do is with the additional bandwidth we've been granted from completing our Tiger Team project is create some new anomaly detection jobs using Elastic's machine learning. These jobs have a security integrity focus in mind. I'm giving you a few examples of at least. So to begin, I want to talk about the data source and event ingestion jobs that we have running. Both of them have the purpose of to ensure that the logs from all of our clients' data sources are arriving to our Elastic SIEMs completely and on time. And so next, detection rule health, abnormal amount of rule runtime warnings / errors for a given rule. The purpose of this job being that our detection rules are to ensure that our detection rules are running smoothly and automatically identifying which ones may require some review. And this is essential for identifying rules that maybe the value that it was searching for no longer exists due to an Elastic update, or there's some other rule runtime errors based on the ingestion time of certain data that it's trying to index for that log and query. And so lastly, abnormal quantity of alerts triggered for a given rule, host, or user. This helps with our alert metrics. So the purposes of this job is to automatically correlate related alerts based on multiple identifiers. This is great not only for kind of like the metric part, but also for correlating security events that may be potentially related based on rule name or like the host name or affected user. So those are just a few examples of the different jobs that we've created and installed across all of our Elastic SIEM clients ever since that we've been able to complete the Tiger Team project. So ending off the presentation, I'm going to pass it back to Dave Howard.
Thanks, Luke. So to wrap this up, folks, our analysts have done amazing work and continue to find innovative ways to leverage Elastic to improve our operations. This has tremendous benefit for our team as the SOC, but also our customers, right? We talked about those value adds. So hope this is helpful. Again, thanks for having us. We appreciate the time.
Thanks, guys.